let's get started. So I'm going to talk a little bit about NGINX and some of the essential pieces of metrics that are useful to keep in mind. My name is Dave McAllister. I am the open source technologist for the NGINX side of the house, 30,000, what's called the 32nd Theater. I've been in open source since before it was called open source, cut my teeth on Samba in 1992, and Linux 0.9.3 in December of 1994 for this. And I've pretty much been in that space ever since. I am owned by 3 cats. I'm used to being ignored, so feel free to do that. And I'm also married, so I have a witness that I do not read minds. So feel free to ask your questions at the same point in time. And just to add to that, by the way, I was in y'all's terms, football ref for 10 years. I am used to having everybody in the world disagree with me, but only half of the crowd at a time. So with that, let's get started around this. NGINX has been a lot of things. It's a reverse proxy, it's a mail server, it's a web server, it's one of the most widely used products in the marketplace. At any given moment, somewhere between 40 to 60% of all the internet's traffic runs through an NGINX product of some sort. And that's pretty much it. But it also is pretty complex. Monitoring, it therefore becomes essential. To keep these things running, we have to know what's going on inside of that at any given moment. And it can be a lot of different things. It can be the underlying structure, the platform, the infrastructure. It can be the application that is being served. It could be NGINX itself. And so if we've got a lot of different pieces that we have to keep track of while we're going through that. There are lots of things, gripping, filters, byte ranges, all sorts of pieces come into play here. And I'm going to be talking about both the open source side, mostly. Unfortunately, my new manager is now for marketing, so I have to include something that says that we have another product that's commercially available. So if you see NGINX Plus, just strike it out and ignore it if you want to. But this is the dashboard. You can see this dashboard. It's widely available. You can just go hit it on the internet and see what's there. And a couple of things that are worth pointing out is that it provides you some basic structures of information, plus it can give you information that's above it. And so for instance, above here, I can tell you that currently one of my servers is got a health monitor and is actually failing an active health check. The application is no longer running, even though the server is up and running. And so there's lots of ways of doing this. I'm not suggesting that this is the right dashboard. Oh, it didn't show up, did it? Oof. This is what I get for trying to be clever. I can see that it's failed. I can tell you all the things, and I can actually go in and take a look closer at what's going on inside of that. So with that, I can now get rid of this, and we'll go back to it. The data is available in lots of different forms, and we'll be talking a little bit about how you can move from the standard way that it's done through Prometheus or the other pieces. But there's lots of different things and data that's inside of there. But this is where the difference starts coming in here. Collecting the data. There is a difference between NGINX open source core and NGINX Plus. We are struggling to get the people to make the change so that the metrics are available equally on both sides. I have been told that's going to happen in the next calendar year. So keep your fingers crossed for me, and I will keep piling on them to do that. NGINX open source is via a status stub module. You load the module into play, and it delivers out a series of metrics to you. Doesn't mean you can't scrape logs, doesn't mean you can't add other pieces to it, but NGINX internally will deliver to you roughly 10 metrics. NGINX Plus has 138. There's a bit of a difference for there. While you're available for visualization, you can visualize it any way you want to. Plus does have that built-in dashboard like I showed you. So let's step into what makes sense for these metrics. Okay, first of all, rule one, I've done a lot of stats talks here. The only metrics that matter are the ones that matter to you, period. If it doesn't matter to you, don't measure it. There is information overload. So keep that in mind. You need to set up what your goals are and what you are trying to answer when you're looking at metrics. So when we look at something like a web server or an application server, these are the standard pieces that we believe are necessary to know that things are working. Request metrics, what's the flow coming into it? Response metrics, how well is it serving out? So it's bidirectional, but they're separate metrics for that. All the way down to, is it secure? Are we safe? Because that's now a pressing concern in all different cases. So while we're looking at all these different pieces, keep in mind that some of these metrics may have lots of different places to pull from, and some of them will be one, maybe two. So active connections, the first thing we talk about here. Number of concurrently active connections to the server. Note that this is concurrently. This is not showing you its peak. It's not showing you the low point. It's showing you exactly what is happening at the time of your measurement. It helps you understand the load on the server for this. And it answers some questions. Do you need to scale the resources? Do you need to optimize the configuration? And in the open source side, this is, interesting enough, connections_active and NGINX connections_active for NGINX Plus. This will show you just what's going on. You saw it in the dashboard earlier. The request rate is the number of requests that are handled. This is not the number of connections. This is the number of requests that are coming in. So a connection can constantly drive requests. And this lets you understand your traffic patterns. This will let you look at how your peaks are happening, as well as what your load balancer is doing for that work. And sudden spikes are very indicative of something happening, whether it's the fact that marketing decided to offer a special deal that they didn't tell us about, which happens ungodly often inside of this, or whether it's something that you suddenly lost a server or that your load balancer has suddenly become unhinged. Then this one, simple, request_time. How many requests over a time period are you getting that are coming in here? It's a built-in variable. It takes the total time taken to process the client request. Not just the active, but how long did NGINX take to process that request? And that will give you the request rate that you're looking for. Response rate is how long does it take for the server to get the request and for the upstream servers to respond. So NGINX comes in as a load balancer web server. It passes this off to the back end. How long did that round trip take? This is something that's really important because this is your bottleneck point. Things come in here, things should spread out, things come in here and they don't spread out, there's something wrong. And so here we're looking at how long request time is, but also what the upstream response time is. And so knowing from when it started to when it comes back gives you that look at the back end behavior for a request. Yes, you can do this with tracing. Yes, it will drive you a little crazy because what you're actually looking at is the client talking to the front end and the front end then talking to a back end. And so it's an ingress type of problem to be able to make sure that you transfer the correct trace ID through it and back out of it. And the easy answer was to build a metric that simply said, we saw you, we know where you went, we know how long it took you to come back. And so that's what we built into play there. Error rates, pretty obvious. 400s, 500s, you can actually define what your error rates look like for this. And this lets you know that there's something going wrong. Earlier today, there was an example where, in this room, in fact, where the transference from AWS to, I believe, Google Cloud came up with a 500 error. And the cloud error was actually because it could no longer find the storage. It's the same sort of error that would show up here. It's not going to tell you where it's coming from. It's simply going to tell you that something failed. If you look at the logs, you will actually get specific details about what was attempted to happen that failed. The metric is a number, the log is the source of truth. So keep that in mind that when you're looking at the status function, the status variable here, it's going to tell you what's going on with an error set, but it's also going to indicate to you that you may need to dig further, and it will fortunately give you a nice little timestamp to which you look for the log issues. So this is one that bugs the hell out of me, and I will be very honest about this one. Applications do not run in a vacuum. they live on an infrastructure. They have memory uses. They have CPU uses. And NGINX does not offer variable to tell you what the memory or CPU usage of the NGINX product on the infrastructure is. We used to, and they decided that they didn't want to do that anymore. However, you can do this using top, htop, vmstat. Any of those tools will actually show you this information. But you need to keep in mind that NGINX is a main process and worker processes, and you need to be able to accumulate them. So it's not just looking at the main process and saying, oh, look, it's barely using memory, because the main process is just handing jobs off to the workers for this. Keep in mind, you got to aggregate them to see what the actual structure looks like. Sorry. And then security side, handshake time. How long is it taking for the security side to create the handshake? This can be another indication of a hardware problem. It can also be an indication that there's a configuration problem. The configuration problem is, generally speaking, not on the NGINX side, but actually on the SSL side. So just keep that in mind, that if you see something go long here, handshake time frame, it's probably a configuration issue on your SSL side. About 20% of the time, we actually do see it as a hardware problem showing up that's got some sort of weird structure piece behind it. And the one that everybody always starts with is throughput. How much data is flowing through at a given moment. So throughput lets you understand what your data flow looks like, what your pipeline looks like. Some of the others, request time, those things, handshake times, are actually giving you different views of a latency issue. And those two pieces are really important. To quote a famous computer scientist, John Massey, Dr. Massey once said that bandwidth costs money, latency lives forever. And so we do know that we are running up against certain things. But bandwidth itself can make a change in the way that your latency restructures. If your pipe is not big enough, you will start throttling, and that will change the latency structures. And then blocked request. The blocked request here, basically status will show you those different theses. Remember, status also will show you the error codes. I brought that one up once before for this. In plus, you'll actually see this thing that says security blocked it. It's the blocked text that says something is wrong that is not a traditional error code. And generally what we see with this is somebody is trying to break in. You're seeing DDoS attacks. This will indicate that probably faster than any of the other variables that have been identified. And then, since we are a caching server, if you are using cache, using it as a reverse proxy, we'll show you what the caching hit ratio is, how often a request is coming in and hitting cache to help you tune your cache structure so that you can get the right things to improve your response time. Okay, so that's a very quick look at these 10 variable categories for this. So what? Each of these things has a different way of showing you information. And so we're going to look at a handful of scenarios here. Now, I'm probably going to dash through these pretty quickly here, but let's talk about them. We're going to monitor active connections, and we see a sudden spike come in. We can see the baseline, what it looks like. We can see normal operations, and then all of a sudden, we break up here. Traffic surge. This is where marketing can come into play more times than you care to think about for this. Is it a DDoS attack? If it is, go look at your status. Is your status showing a lot of 404s, 403s? Or is it a resource limitation? Do I have a load balancer problem? This will start giving you the indications of the questions that you can start trying to answer just based on basically 3 metrics. And so those 3 metrics will give you that overall viewpoint. Now, let's take the exact same thing and say that we're looking at active connections and we're doing a gradual increase. Things are sloping up, but slowly. And so your active connections means around 500. But over time, we're seeing 500 to 700 to 900 to 1,000. My 0 fell off for this. We're seeing request times float up. We're seeing response times float up inside of here. We're also seeing error rates float up at the same point in time for this. Here's where we look at this. Are we seeing more traffic coming in? Are there more users that are connected into here? If they are, we need to start scaling resources. If there's not, Are we seeing something that's causing a degradation? Things are slowing down. Maybe we're just overwhelmed by this. Maybe we've only got 2 systems serving and we need 3. Again, it's a resource pieces here. And then finally, is it a vertical scaling issue or is it a horizontal scaling issue? Particularly in the microservices environment, are we being throttled on a particular point of contact, particularly in the back end? Those pieces can mean that you need to upgrade your hardware or that you need to add more servers. And so that's the horizontal vertical structure for a server environment. And then 3 in this is we're seeing a lot of changes. This thing is going up and down like crazy for this. Are we seeing intermittent traffic? If so, why? Is this expected behavior? And again, your metrics over time will show you what your expected behavior looks like for here. It can be caused by a periodic event. It can be, depending on your time frame, it could be the fact that the World Cup kicks off and all the traffic goes crazy for a period of time. So there's lots of different things that happen. Google actually suffered this back in, I want to say 2010 or 2012, I've forgotten, when Brazil lost in the World Cup. And the Google servers all melted down. And they melted down because this was a periodic event that no one expected. Amazon had something similar when they introduced a new microservices right before Prime Day started, that they forgot to turn on scaling. And so everything throttled through one point. But what happened was the volume of the connections, on that case, went way down. The volume of connections on the Google went way up. Keep in mind that metrics go both ways. That's just something I have no idea how to explain occasionally to my engineering, actually my engineering director, he's pretty smart, and to some of my directors, that metrics don't just go up. So those are the pieces. So let's take a look at another set here, and this is blocked requests. So this is where we've got lots of information coming in here. We've seen a spike in blocked requests, 40443 showing up here. It could indicate ongoing security threat. It could be unauthorized access. It could be brute force. It could be SQL injections. It can be lots of different things here. The first place that you would probably look is your firewall rules and see what's happened in the firewall rules for that. Also, keep in mind that in particular with blocked request, this can be a false positive. It is very easy for something to generate false positives when they're really not happening and legitimate traffic is being blocked. Again, firewall rules are a number one source of this, but there are other underlying considerations, particularly in the back end. Somebody introduced something new, somebody added a piece of JavaScript code to the client side, and all of a sudden things are getting blocked. So keep that in mind when you're looking at that. But this is, again, spiked requests, and not bad, but nonetheless, they are going up. Gradual increase. We're seeing that gradual increase coming in here. This is an indication that your servers are becoming more frequent targets. Okay, so if you're seeing a lot of blocked requests and they're slowly creeping up here, you probably have somebody that's trying to get into your system, but they're being very clever about it. And so keep that in mind that when you're looking for this, keep your eye on this. And you may need to adjust some security rules for this. You may need to actually look in and look at the logs and make sure that these are real users that are coming in here. Until they started blocking login after a certain number of attempts, I did once see, I think it was British Petroleum, where we had a guy spend an entire day trying to remember his password and just type his password incorrectly for almost 8 solid hours. And now you block the people from doing those things. But nonetheless, it was one of those indications. This type of thing, we probably wouldn't call it an individual user, but it is an indication that something is going on that is increasing over time, causing a problem with your system. And then same thing, high variability, up, down here. Could be probing attempts, could be intermittent attacks of these. Number one suspect when it comes to this is automated scripts going in and testing your system. So anything that you start seeing a lot of blocked attempts on, start thinking security and start hardening your background and checking your logs to find out what's going on. It can also, by the way, be a load balancer issue. It can be a proxy issue. It can be an application problem. But the first thing to do is probably check the logs for a lot of unauthorized attempts that happen there. So that's a quick view of some of these places here. We also provide an open telemetry module for this, and this allows us to do tracing that goes through NGINX. So you can trace NGINX, but you can also trace through NGINX. And so what we're doing is passing the OpenTelemetry trace ID correctly through the system, because remember that once you hit the load balancer, where it goes to next is a persistent connection while it's a connection. So you need to be able to trace it back and forth as it passes through here. We looked at the community one. The community one is great. It does a lot of things. But what we found was that it took about 50% additional CPU processing. And NGINX number one creation thing was around being performant. The 10K problem in 2002. How do you do 10,000 active connections at a time on a web server? And that's been one of our rules of thumb ever since we did this, was that anything we have has to perform extremely well and extremely efficiency. So they wrote it. The native module that NGINX produces that lives inside of NGINX runs about 10% overload. Observability always comes at a cost, and it can come at a cost in storage. If you're storing all your traces, it can come at a cost of CPU. It can also come at a cost of bandwidth. And so we've got it down to about 10%. The nice thing is that setup and configuration is exactly the same in the same config file that NGINX itself is into. There are not two things to keep track of. It's all just built into that. And you can turn it on and off and change the variability while it's running. So you can basically throttle it or push it up at the same point in time. Pre-built, it's there. So what happens is the response comes in, the request comes in for the client, gets handed off to the NGINX open source project here, and it talks to the application. At the same point in time, the NGINX piece is tracking it using an OTLP, going off to a collector, going into the web apps, going into the storage. And so all of this is being run inside of the NGINX to track both the inbound client as well as the application aspects in an open telemetry environment. Pretty simple. Example configuration over here, OTel exporter tells me where I'm sending this to. That sends it off to that piece. What it's listening to, the server is listening to, the trace that you want the trace context turned on so that they get the trace IDs here, and then you want the proxy pass for the backend for this allows me to come back and say, I want to know not just what the client does, but what the backend does. And so that's where it all combines together. There's 4 or 5 of other of these, but they're pretty straightforward. You can also do Prometheus. Prometheus is probably the de facto standard for metrics. Sorry, everybody else, there's lots of discussions, but Prometheus has won the battle. Just give up for this. With NGINX, we can either read the status module, we can read the plus API, and get the various pieces directly to this. For an example, if you look at this, these are some examples of what you can get here. Connections accepted is a counter, connections active is a gauge, the standard things that you expect to see in Prometheus. Both the OTel module and the Prometheus module are open source. You can find them out on our GitHub site for that and move it forward. So summing up, it's not just the metrics, it's the questions you want answered. The metrics will give you the best way to look at what's happening here. The metrics are distinctly different, right now at least, and we're working on it, between core and plus. Sorry, I'm going to fix it one way or the other. If I have to steal the code and shove it in there, I'm going to do it. Other projects like Prometheus, like OpenTelemetry, can make your life a lot easier. And always, I'm an old log guy, log scraping is always an option. And in fact, our own products will scrape logs as well. However, I love this quote. This came out, Brian Kernighan, Unix for Beginners, 1979. Most effective debugging tool is still careful thought, coupled by judiciously placed print statements. Metrics are one form of print statements, just like traces are. And so keep that in mind, that no matter what they tell you, it's still dependent on you to figure out what they're saying. And with that, you can find me on our community. You can find me on LinkedIn. I'm Dave Mack. I've been around. I was the 1,013th person to join LinkedIn. They sent me an actual certificate that told me what my number was for this. And then if you want to find the OTel product set or the Prometheus one, you can look here on this one as well. And with that, and 20 seconds left, thank you so much.
Any questions?
Any answers? Yes, my internal bio, by the way, says ask anything you want to, don't expect answers. So,
thanks. Good talk. So this is relates to something I've been doing recently. I've been setting up NGINX, a caching layer in front of one of our backend APIs. And the default open source metrics, like you say, they're quite restricted.
yes.
So I've compiled the VTS module that exposes more or less the plus metrics as in Prometheus format. Is that something you've looked into or aware of or would recommend?
I actually think that's a very interesting approach. I'd love to, I'd have to think about it a little bit more, but it might get around some of my current shortcomings a lot easier than I'm currently getting around them. Because I came out of a company called Scalar, and Scalar did log search, and so I'm very used to scraping logs, but I'm tired of having to write it myself every time. So, yeah, I like that.
Okay, one more.
Thank you for the talk. Do you ship any default alerting rules together with these metrics?
I'm sorry?
Do you ship some default alerting rules that user can deploy to employ these metrics?
Yeah, probably. Sorry, my brain went off into two different ways of trying to say this. Yes, you could do the calls. Plus actually has the capability to do that pretty easily. I don't like talking about Plus, cost money. For that, you'd have to, you could probably use, I don't have a good answer for that. Sorry. I'm sitting here, my brain is coming up with like things, but anything I say is probably a 50% shot of being wrong. So I don't have a good answer.
Okay, thanks, I appreciate it.
Sure.
All right, one last.
If not, I thank y'all for sticking around, finding room 3, because I know it's an interesting little trace of passages that all look alike for this, and I will turn it back over. Thanks.